Antiderivatives are the counterpart of derivatives in mathematics, and derivatives is something you've worked with all semester. So the antiderivatives is going to be the opposite operation from that. So remember that when you did derivatives, you were finding the slope of a tangent line, essentially like y over x, the slope at a given point. The antiderivative is going to instead give you y times x, the area of a curve, instead of the slope of the tangent line. So let's think about ways that you can calculate antiderivatives. Well, you can always think about it as the antiderivative of something is what, if you took the derivative of it, you would get your function out. So, for example, the antiderivative of 2x, let's say f of x equals 2x. The antiderivative notation usually is then a capital. So the antiderivative of this is, another way of saying this is, the derivative of what function gives you 2x, and that is definitely x squared. But here's the problem, is that if that was x squared, that would work, but if it was x squared plus 5, that would work too, because if you took the derivative of x squared plus 5, you would still get 2x. And in fact, if you added anything or subtracted anything from x squared that was a constant, it would still work. So what you have to do when you do the antiderivative, you always have to add, and you usually call that constant c, constant of integration, and that can be any number that will still keep this to be true. So let's think about general rules then for antiderivatives. So for derivatives at your most basic, you had a power rule. So for antiderivatives, there's also a power rule. So if you have f of x equals x to the n, where x, you have x in any power, the antiderivative of that is going to be the opposite. So remember, with derivatives, we brought the power down, lowered it by 1. What we're going to do with antiderivatives is now raise the power, and instead of multiplying, we divide by that new power. And of course, we'd have the plus c. So that's the general form of the antiderivative for any power. Now with derivatives, if we had a constant, it would just stay there. With antiderivatives, same thing. If you have a constant, it just stays there. So you can think of this, let's approach this one we just did using the power rule. Let's do this here. The 2 stays there. The antiderivative of x is x to the 2 over 2. So you can see here we get x squared plus c. So that's the general power rule for antiderivatives. What I want to note is that there is no product rule or quotient rule for antiderivatives. It doesn't work that way, and you're not going to approach it in this class. So you don't have to worry about that. On the other hand, if you get something that looks like it's a product, you always need to, or a quotient, you need to simplify it first, because you can't do it if it's a product or a quotient by just using the power rule. So this is where separating fractions comes in handy, or foiling out expressions so that you get them term by term, and then you can just do the antiderivative term by term. There's a variety of other things you need to do for antiderivatives, and by the way, antiderivatives are also called indefinite integrals. So, for example, trig functions, they're all just the reverse of what they were before. So if the derivative of sine is cosine, the antiderivative of cosine would, of course, then be sine. So for the trig functions, you can always just think of them as going in reverse. The one power of x that you can't do in the power rule is if n was -1, because you would get 0 on the denominator. So let's think about that case. -1 power, meaning 1 over x. This one is pretty easy to think of. What function's derivative is 1 over x? That's ln x. So that's the special case, so I should probably put that here. N cannot equal -1. You take the antiderivative, you get ln x. So you have, if you get down to it, you can always think of it as the reverse of just differentiating but knowing the power rule there is pretty handy. Remember that constants always stick around just like they did with the derivatives. And in the same vein here, if n was equal to 0, anything to the 0 power is 1. So what this tells you is if you were just doing, if your original function was just 2, and we wanted to know what the antiderivative of that was, all you have to do if it's a number is just multiply it by x. Because the derivative of that is always just going to be that number. So these are the basic rules for antiderivatives. They're, follow along straight from the derivative rules for the most part, but that's going to be really handy for these last couple of tests.